All right, good morning, everybody. Did a lot of definitions yesterday. We're going to have a few more today, plus work with a little bit. So, a couple of things that we did yesterday were let me get my pen out. I like my calligraphic pen. All right, so we talked about an arc, a minor arc, semicircle, and major arc. So, today we want to talk about a central angle. Central angle is just what it sounds like. It's an angle whose center, whose vertex is the center of the circle. What do I mean by that? Well, here's a circle, right? Let's call this circle O. I hate when it does this wrong thing, but whatever. I like Times New Roman for our stuff. And so let's make this italic. Circle O. All right, so we have circle O here. So if I wanted to see what a central angle was, a central angle is made by two radii whose vertex is the center. Two radii whose vertex is the center. So let me put that there. There's one radii. There's two radii. Right? Whoop, went a little long, but that's okay. So we got to name these points. Let's call it point A, and we'll call it point B. I prefer italics, but whatever. All right, there's B. There's A. So here you see you have an angle. All right, we have this angle here. That is a central angle. A central angle is equal to the arc. These two have the same measure. So if I told you that this angle here, theta, equals, oh, I hate this. Let me try this. Get rid of all these. All right, so there's our central angle right here. Ooh, went thick. That's okay. All right, so that's our central angle. Now, suppose I told you it was, I don't know, 110 degrees. Right? This angle's 110. So the measure of angle AOB is 110 degrees. It's probably not quite 110, but I just felt like using that. That means clone it, that this arc is also 110 degrees. A central angle is the same as the arc. Central angle means that the vertex is at the center. These two are going to always be the same measure. So the measure of arc AB is equal to the measure of angle AOB. Those are the same. Always going to be the same. Central angles are the same as the arc. The arc is the same as the angle. If I knew the arc, I know the angle. If I know the angle, I know the arc. Which is just what I said here. This is just one of the things from your textbook that you might notice. I've gave you those all year. So what if I wanted this bigger arc? If I wanted this bigger arc over here, right? If I'm talking about arc AB, that's a minor arc. That's why it's telling me between here and here. AB is 50 because angle ACB is 50. But what about arc ADB? Going in the other direction. Right? 3 letters. It's a major arc. Well, a whole circle is 360 minus the 50 we know. So this arc back here you would find by subtracting this arc from 360 is 310 degrees. So let's practice a little. Well, that's really the same problem, isn't it? 50 degrees. That's fine. So angle AOB is 50 degrees. What would that mean, the measure of arc? AB is equal to. That would also be, I don't want a calyx for that. That would also be 50 degrees. See how I do that? I'm pretty good, huh? Yeah, okay. So these are the same. They will always be the same. So what would that mean that arc AC is equal to? What would arc AC equal? Well, CB is a diameter. A diameter divides a circle into 2 semicircles, each of which is 180 degrees. So if I wanted to find arc AC, this arc here, right? Suppose I wanted to know what this arc was. Drawing here is tough, ladies and gentlemen, so you have to forgive me. I want to know that arc. Well, that would be 180 minus 50 degrees, which is equal to 130. Right? So that's how I would find this arc. That will be 130 degrees. 130 degrees. That's over here. Because 130 plus 50 is 180. This is a semicircle. Yes, semicircle. So arc CDB would be 180 degrees. I'm not going to keep putting in the degree symbol. You know what's there. So now what if I wanted arc ACB? Well, I could add 130 and 180, couldn't I? What's 130 and 180? 310. Okay. Or 360 minus 50. Right. 360 minus 50 equals 310 degrees. So that would be this arc here. If I want, do a different color. If I want to know from here all the way over to here, all I'd have to do is subtract. So let's try another one. What would the measure of each arc of circle P, where RT is a diameter? So we know this is a diameter. I don't know if I can move just this diagram. I can. Good. Maybe make it a little bigger. There we go. All right. So what's the first thing we're asked to find? First thing we're asked to find is RS. Where is arc RS? This is arc RS. Well, this is a central angle. This is going to be 110 degrees because the central angle is the same as the arc. The arc is the same as the angle. What about arc RTS? Follow the letters. Follow the order it tells you to go. Start at R, go to T, then to S. Start at R, go to T, go to S. Well, a whole circle's 360. 360 minus 110 is equal to 250. So arc TS is equal to 250 degrees. Arc RST. RST. R to S to T. That, well, if this is a diameter, that cuts a circle in half. That has to be 180 degrees. Postulate, you don't really need to know this. Arc addition is the same as angle addition. It's the same as segment addition. If two arcs are next to each other, we can add them together and get the whole arc. That's all that says. The whole is equal to the sum of its parts. Haven't heard me say that in a while, have you? So, how would I find arc GE? Arc GE. I need this arc. Well, this central angle is 40. That means arc GH is 40. That means arc HE is 80. 40 plus 80 is 120. How about GEF? GEF. GEF. Follow the order of the letters. G to E to F. Well, I know this part, right? We just found that was to be 120 plus 110. That's how much further I went, because this is 110 out here, right? 110 plus 120 is 230 degrees. And arc GF. GF. What color didn't I use? Green. That's over here. Well, that will just be, right, this number subtracted from 360, because I know this whole part now. 360 minus 230 is 130 degrees. All righty. Identify the given arc as a major arc, a minor arc, or a semicircle, then find the measure of the arc. All right, TQ. Well, what would TQ be? What do we say a major arc was? Greater than 180. Is TQ? Is here, I might as well use this. All right, so 120. Central angle. Let's see if I can move. Yeah, I can. Okay. So that has to be 120. So arc TQ is 120. It is a minor arc because it's less than 180. Arc QRT. QRT. What would that be? Well, if I know TQ is 120, 360 minus 120 is 240. So this whole arc out here, right? QRT, QRT has to be this 240. And is that a major arc or a minor arc? Well, it's greater than 180, so it's a major arc. How about TQR? TQR. Well, two arcs can be added together. If I know this is 120, we did that before. If this angle is 60, what does that make that arc? It makes that arc 60. So if that arc is 60, 120 plus 60 is 180. So the measure of arc TQR is going to be 180 degrees. What is 180 degrees? Is it major, minor, or a semicircle? It's a semicircle. So TQR would be a semicircle. Arc QS, asking a whole bunch of stuff. How do I find QS? Well, notice I have these three angles here. What is 120 plus 80 plus 60? That would be 260. Yeah, I stayed in green. That's fine. 360 minus 260 is 100 degrees. So this angle here is 100 degrees. If that's 100 degrees, that makes this arc 100 degrees. So arc QS would be 100 plus 60, which is 160 degrees. We have everything in there now, so we can just look at it. That's also a minor arc because it's less than 180, or TS. TS is here. All right, this piece here, same as the central angle, so that has to be 80 degrees minor arc, and RST, again, 100 plus 80 is 180. That makes this a diameter, by the way. That makes this a semicircle, which makes it half. Theorem, congruent circles theorem. Now, because there's no Regents this year, I haven't decided yet, but there's a pretty good chance you're not going to have to do circle proofs. Everybody right now is going, oh my God, thank you, Mr. Castro. You're quite welcome. But if we did have proofs, we'd have to have theorems. And if we had theorems, one of them says that two circles are congruent if and only if they have the same radius. That's all that means. We'll see. We might have to use that other than proofs. Maybe I will give you a circle proof just for fun. Congruent central angles theorem. This is important as well, but mostly for proofs. In the same circle or congruent circles, two minor arcs are congruent only if their central angles are congruent. So if these two angles here are congruent, then the arcs have to be congruent. That's really, really, really about proof. And we're not going to be doing much proof. Are those red arcs congruent? Well, they're only congruent if their central angles are the same. Here the two central angles are 80, so these two arcs must be congruent. Here, what's the central angle? It's a right angle. That's 90 degrees. That means this arc is 90. Now be very careful. This arc is 90. At some point, we're going to talk about arc length. Arc length is not the same as the measure of the arc. This arc, both of them are 90, but obviously this is a longer arc than this one. So we will talk about arc length at some point. This is just about the measure of the arc. These two circles, are they congruent? They are, because they have congruent radii. They have congruent central angles, therefore UV is congruent to YZ. 145, congruent, congruent. Circles aren't, but they are. Another theorem, all circles are similar. What does it mean to be similar? Hopefully you recall that similar figures are figures that can be mapped to each other by a transformation. How could I get this circle onto this circle? What's the only thing that makes them similar? Yes, an enlargement or a reduction. So I can either shrink this circle and put it on here, or I can enlarge this circle and put it on here. And that's really it, ladies and gentlemen. The biggest key today that I want you to take from today is central angles. Right? Central angles are the same as the arc. Arcs and central angles are the same. Again, just want you to watch the video. I'm not going to give you a formal assignment today. I just want you to be aware of these things as we move through the rest of this unit. A lot of vocab. Just please be sure you know a central angle is the same as the arc, and arc is the same as the angle. Have a great day, everyone. Take some notes during this video, and we'll talk again tomorrow.